Are Pluto and Neptune on a collision course? Join us as we unravel the mysteries of Pluto's orbit and its potential clash with its distant neighbor, Neptune. Today, we're diving into the intriguing possibility of a celestial collision between Pluto and Neptune. Once considered the ninth planet, Pluto's reclassification as a dwarf planet hasn't diminished its astronomical significance. Recent reports suggest that Pluto's trajectory might intersect with Neptune's, sparking concerns among scientists and space enthusiasts alike. Stay tuned as we explore this cosmic conundrum. Pluto, with its highly inclined and elliptical orbit, continues to perplex astronomers. Unlike the orbits of the major planets, Pluto's path is unique, raising questions about potential collisions with Neptune. The gravitational influences of Neptune and other planets play a crucial role in stabilizing Pluto's orbit and preventing catastrophic events. Computer simulations reveal the delicate balance of forces maintaining Pluto's stability over billions of years despite its chaotic nature. Renowned experts like Neil deGrasse Tyson and Michio Kaku have raised alarms about the consequences of a potential celestial clash. Let's dive deeper into their perspectives and the complexities of Pluto's orbit. Neil deGrasse Tyson, a prominent astrophysicist and science communicator, played a key role in the reclassification of Pluto from a full-fledged planet to a dwarf planet. His insights into Pluto's reclassification highlight the dynamic nature of scientific understanding and the importance of adapting to new information. Tyson's cautionary stance reflects a broader concern within the scientific community about the stability of celestial bodies and the potential impact on Earth. While the likelihood of a collision between Pluto and Neptune is extremely low, Tyson emphasizes the importance of vigilance. Monitoring celestial dynamics for any potential threats is crucial. By raising awareness about the complexities of celestial mechanics and their implications for our planet, Tyson encourages a proactive approach to planetary defense and space exploration. On the other hand, Michio Kaku sees Pluto's orbit as an opportunity to glean valuable insights for future space exploration endeavors. As a theoretical physicist and science popularizer, Kaku explores the deep connections between theoretical physics and celestial mechanics. He views Pluto's orbit not only as a scientific curiosity but also as a practical resource for navigating the solar system effectively. Kaku's perspective underscores the interdisciplinary nature of space exploration, where insights from theoretical physics inform practical applications in astronomy and planetary science. By studying the complexities of Pluto's orbit, scientists can gain valuable knowledge about gravitational interactions, orbital dynamics, and long-term space missions. Kaku's optimism about the potential of space exploration highlights the transformative impact of scientific inquiry on our understanding of the universe and our ability to explore it. Pluto's orbital path presents a unique challenge due to its inclination and elliptical shape, diverging from the orbits of major planets. Despite its eccentricities, Pluto's path intersects with Neptune's, prompting questions about potential collisions. The gravitational influences of other planets, particularly Neptune, play a crucial role in stabilizing Pluto's orbit and preventing catastrophic events. Computer simulations reveal the delicate balance of forces that maintain Pluto's stability over billions of years despite its chaotic nature. Tyson's insights into Pluto's reclassification highlight the dynamic nature of scientific understanding and the importance of adapting to new information. As a prominent astrophysicist and science communicator, Tyson played a key role in the reclassification of Pluto from a full-fledged planet to a dwarf planet. His advocacy for scientific accuracy and clarity underscores the need for continual learning and reassessment in the field of astronomy. The study of celestial mechanics extends far beyond the orbits of individual planets like Pluto and Neptune. It encompasses a wide array of phenomena that provide valuable insights into the dynamic nature of the universe and its impact on planetary systems. One such phenomenon is the existence of rogue planets, which drift through space without orbiting a star. These solitary wanderers, expelled from their original star systems due to gravitational disturbances or other celestial events, introduce an additional layer of unpredictability to the cosmos. While the chances of a rogue planet directly colliding with another planet are slim due to the vastness of interstellar distances, their presence underscores the complex interplay of gravitational forces in the universe. Furthermore, galaxy mergers represent another fascinating aspect of celestial mechanics. When galaxies collide, the gravitational forces at play can dramatically alter the trajectories of stars and planets within them. Although direct collisions between planets during these cosmic events are rare, the gravitational disruptions can lead to orbital shifts, planetary ejections, or even the formation of new celestial bodies. Planetary bombardments, such as the late heavy bombardment period in our own solar system's history, offer crucial lessons about the dynamic nature of planetary systems. During this chaotic phase billions of years ago, the orbits of small bodies like comets and asteroids were perturbed by the gravitational influences of the outer planets, leading to increased impacts on the terrestrial planets. This bombardment not only shaped the surfaces and geological histories of planets like Earth but also played a role in delivering essential materials like water and organic compounds, influencing the development of life. In essence, the study of celestial mechanics encompasses a diverse range of phenomena that shed light on the dynamic and ever-changing nature of the universe. By examining these events, astronomers gain a deeper understanding of planetary systems, their evolution, and the underlying physical principles that govern them. As technology advances and our observational capabilities improve, we continue to uncover new insights into the mysteries of the cosmos, furthering our knowledge of celestial mechanics and its profound implications for our understanding of the universe. The mysteries of Pluto's orbit have long intrigued astronomers and physicists alike. Its journey around the Sun, taking 248 Earth years, is far from a simple elliptical path. Pluto's orbit is highly inclined, tilted at 17 degrees to the plane of the solar system, and highly eccentric, meaning it's stretched out more than most of the planets. This unique path brings Pluto closer to the Sun than Neptune for 20 years out of its lengthy orbital period, sparking the question, could these two celestial bodies ever collide? The answer lies in the intricate ballet of celestial mechanics. Despite appearances, Pluto and Neptune's orbits are in a stable resonance with each other. This means they are locked in a gravitational dance that prevents them from ever coming too close. Specifically, Pluto orbits the Sun twice for every 3 orbits of Neptune, a relationship known as a 2-to-3 mean motion resonance. This precise ratio ensures that Pluto and Neptune are never in the same region of space at the same time, thus averting the risk of collision. This resonance has been maintained for billions of years, a testament to the stability provided by the gravitational influences of Neptune and other planets in our solar system. Computer simulations of Pluto's orbit over millions of years demonstrate how this delicate balance of forces continues to protect Pluto from catastrophic encounters, even as its orbit wobbles and shifts over time. Neil deGrasse Tyson, known for his role in the reclassification of Pluto, often speaks about the dynamic and ever-changing nature of scientific understanding. He emphasizes that as we learn more about our universe, our definitions and classifications must adapt. Tyson's role in demoting Pluto from planet status was not about diminishing its significance but about refining our understanding of what constitutes a planet. His insights remind us that the universe is far more complex and nuanced than our initial categorizations might suggest. Tyson's caution about celestial mechanics extends beyond Pluto and Neptune. He advocates for vigilance in monitoring all celestial bodies, understanding their paths, and preparing for potential threats. His emphasis on planetary defense highlights the importance of continued research and readiness. Although the risk of a collision between Pluto and Neptune is minimal, the study of their orbits provides valuable lessons in how we can protect our planet from other potential cosmic hazards. Michio Kaku, on the other hand, views the study of Pluto's orbit through a lens of opportunity. Kaku, a theoretical physicist, explores the deeper connections between celestial mechanics and the future of space exploration. He sees Pluto's unique orbit as a gateway to understanding the forces that govern our solar system and beyond. For Kaku, the study of Pluto is not just about avoiding potential collisions but about leveraging our knowledge to navigate and explore the cosmos more effectively. Kaku's optimism about the future of space exploration is rooted in the belief that every piece of knowledge we gain about our solar system has practical applications. By understanding the gravitational interactions and orbital dynamics of Pluto, scientists can develop better models for space travel, potentially aiding in the planning of long-term missions to the outer reaches of our solar system and beyond. Kaku's perspective underscores the interconnected nature of scientific discovery, where theoretical insights can lead to practical advancements in technology and exploration. Pluto's reclassification as a dwarf planet has not lessened the intrigue surrounding its orbit. Instead, it has opened new avenues of inquiry into the nature of celestial bodies and the dynamics of our solar system. The debate and study surrounding Pluto serve as a reminder of the ever-evolving nature of science, where new data and perspectives continually refine our understanding of the universe. The potential collision between Pluto and Neptune, while a fascinating topic, is just one example of the broader study of celestial mechanics. Astronomers also study rogue planets, galaxy mergers, and planetary bombardments to gain a deeper understanding of the universe. Rogue planets, which wander the cosmos without a star to orbit, challenge our understanding of planetary formation and stability. Their unpredictable paths add a layer of complexity to the study of celestial dynamics. Galaxy mergers provide another dramatic example of celestial mechanics at work. When galaxies collide, the gravitational forces involved can dramatically alter the trajectories of stars and planets within them. Although direct collisions between planets during these events are rare, the resulting gravitational disruptions can lead to significant changes in the structure and composition of the galaxies involved. Studying these mergers helps astronomers understand the forces that shape galaxies and the evolution of the universe on a grand scale. Planetary bombardments, such as those that occurred during the late heavy bombardment period in our solar system's history, offer critical insights into the early stages of planetary development. These events, driven by the gravitational influences of giant planets, resulted in increased impacts on the terrestrial planets. These bombardments likely contributed essential materials, such as water and organic compounds, critical to the development of life on Earth. By studying these phenomena, astronomers gain a more comprehensive understanding of the dynamic nature of planetary systems and the forces that govern them. The knowledge gained from these studies enhances our understanding of the universe and informs our efforts to protect our planet from potential cosmic threats. As we continue to explore the mysteries of space, each discovery brings us closer to understanding the complexity of our universe. The study of Pluto's orbit is just one chapter in our ongoing quest for knowledge. Join us on this journey of exploration and discovery as we uncover the wonders of the cosmos. Thank you for watching another episode of our channel. Don't forget to subscribe and click the video on your screen for more captivating content like this.